Okay, so find a formula for the general term of the sequence, assuming the pattern of the first few terms continues. Okay, so what are we doing here? So we're looking at a sequence. So now we're in 9, this is 9.2, and the title of the section, this is 9.2, arithmetic sequences. So we're looking at this and we're saying, what's the pattern? What's happening from number to number? What's going on? Well, in this case, it's going down by 2 each time. See how it's going down by 2 each time? Like that? So it's just going down by 2 every time, right? 3 goes down by 2 is 1, goes down by 2 is -1, down by 2 is -3, right? If you wanted to look on a number line, here's a number line, and I put like 0 on the number line right here, and this would be 1, 2, 3, -1, -2, -3, -4, -5. So the numbers are right here at 3. And then the next one is at 1, and then at -1, and then at -3, and at -5. See how it's just jumping back by 2 every time? Every time it's a jump back of 2. All right, so anyway, so it's going back by 2 every time. And then what it wants us to do is find the for the nth term. That's a formula. What that means is the formula for the nth term. So in other words, I want a formula so I could find any term, because we all see the pattern. And we all look and go, oh yeah, I got it. It goes down by 2, down by 2. Okay, yeah, but can you give me the 100th term? Can you give me the 79th term? So there's more to dealing with a pattern than just observing that it's a jump of 2 every time. That's a good beginning. That's a good start. It is going down by 2 every time. But can we now use that to jump all the way to like the 79th term or the 108th term or whatever? Can we jump anywhere we want? Well, for that, we need the formula, and the formula is in the notes. So here's the notes. This is the exam 5 notes, right near the end of the exam 5 notes. I've got some formulas for you. Arithmetic sequence. This is an arithmetic sequence because you're adding or subtracting the same number every time. The nth term formula is right here. A sub n equals a1 plus n minus 1d. So let's use that formula. There is our formula. So an is a1 plus n minus 1d. So there's the formula we're going to use. Okay. So now what does A1 mean? Well, and you can see down here in the notes, A1 is the first term. AN is the nth term. N is the number of terms, and S sub n is the sum. And oh yeah, D, I should mention what D is. Yeah, they didn't mention D, did they? D is the difference from term to term. So all right, so let's get so A1 is the first term. And D is the D stands for difference, or the jump from term to term. The difference or the jump from term to term. So in our case, the D is -2, isn't it? That's the jump. That's the difference from one term to the next. It goes down by 2 every time. So the difference is -2. The first term, well, that's 3. So A1 equals 3. So what's our formula then? A sub n equals 3, right? Plus parenthesis n minus 1 times D. What's D? -2. And you probably can just type it in like that, but I'm going to go ahead and distribute it. So I'm going to take that -2 and go bonk, bonk. and I get a sub n is 3 minus 2n plus 2. Does that make sense? That minus 2 went there and there. And so a sub n equals 3 plus 2, 5 minus 2n. Like that, 5 minus 2n. There's the formula. A sub n is 5 minus 2n. So notice what we could do with that now. Well, first off, is let me run over what happened again. So this is what we call an arithmetic. Why do we call it arithmetic? In fact, let me write that in some big letters here. This is arithmetic sequence because we add, arithmetic means adding and subtracting, right? When you first learned arithmetic when you were young, you learned how to add and subtract because you add and subtract to go from term to term. In particular, we're subtracting 2 every time, right? So if you subtract or add the same number, I should say same number, because we're adding or subtracting the same number from term to term. We're subtracting 2. That's an arithmetic sequence. The formula is an is a1 plus n minus 1d. The d is the difference from term to term, the jump, which is the negative 2. The a1 is the first term. So we go 3 plus n minus 1 times negative 2. Distribute that. We get 5 minus 2n. Now, what that form is, we could easily now find any term we want. We could say, what's the 97th term? We'll just plug in a 97 for n, and bang, crank out that formula. You can find the 97th term. So this formula will allow you now to jump anywhere. That's why we care about it and why we want to find it. So there we go.